Assalamualaikum warahmatullahi wabarakatuh and a very good day to everyone. Okay, we meet again in the next slide. The topic for this slide is elements of probability theory. Okay, in this section or in this slide, we're gonna learn more about the introduction of probability and how do you define probability and the laws of probability. Okay, all right, so let's move on. Okay, before that, there are several points to ponder. Activities pertaining electrical and electronic systems are basically surrounded by a lot of uncertainty. For example, the chances that people will be hit by lightning during rainy seasons, the chances that power system fail, the accuracy of an error detection mechanism, and etc. We can never be certain and we can never expect this kind of thing to happen or this kind of events to occur. However, it is important that we are able to predict this event. As such, we could take safeguards in protecting the power system or the power plant infrastructure, for example. Therefore, there is the importance of probability for us to predict and in a way to these events to occur. Okay, the general overview of probability. Okay, the experiment is alien encounter. The events is A, an alien encounter in Malaysia. So if let's say the probability of A, which is the alien encounter in Malaysia, it might be zero, right? Maybe there are some. Okay, as compared to Toyo encounter, or should I say a ghost encounter, and for B, a ghost encounter in Malaysia. So the probability of a ghost encounter in Malaysia is much higher than alien encounter in Malaysia. So that is very general, very generally speaking, of the probability. Okay, probability allows us to use the sample data to conclude about the populations, and apart from that, probability distribution models some random variables of the populations. And in conjunction to that, probability can be calculated given data obtained from the observation that were made. An experiment is the process by which an observation or the measurement is obtained. I believe that you are aware and you must have done your experiment before, right? And having said that, an event is an outcome of the experiment, right? So that's why you have to know. In statistic, event is defined as the outcome of your experiment. Okay, for example, the experiment is to record an age, and the event of A is person is 30 years old, and for the event of B is the person is older than 65 years old. So this can be the social science study, or maybe in the one class about the age of the class. So the event of A could be the person is 30 years old and B is older than 65 years old. Another experiment is, for example, you toss a dice, right? You toss a dice. Dice have like six surface, and the event A is to observe an odd number. So it could be how many? 1, 3, 5, right? So it can be 3. And B observed a number greater than 2. So you can say that. Of course, you can learn from there, right? Okay, moving on to the next slide is the sample space. Okay, an event that cannot be decomposed further is called a simple event, denoted by E with a subscript. Each simple event will be assigned a probability, measuring how often it occurs. The set of all simple events of an experiment is called the sample space. Okay, so these are the basic terms that you have to know really well in statistic. Okay, for example, let's say to taucidized, the S, which is the sample space, which is the set of the all simple events, which includes E1, E2, E4, E3, E4, E5, E6, right? Okay, the event is to observe an odd number, so it should be E1, E3, E5, and B is to observe a number greater than 2, which is 3, 4, 5, 6, and C observe a 6, which is of course 6, E6, and D observe a 3, of course it's going to be E3. Okay, so that's the definition of sample and the event. Sample and spaced. Okay, overview of the event relations. Okay, in a nutshell, event relation can be roughly divided into three main categories. The first one is unions, the second one is intersections, and the third one is complement. All right. There are formulas to count the probability of each event relations. So let's start with the first one, which is the union. The union of two events, which is A and B, is the event that either A or B or both occur when the experiment is performed. So in this case, we write A is the union of B. In the meantime, intersection of two events, which is A and B, is the event that both A and B occur when the experiment is performed. Meaning to say only this part, which is the intersection, and we call it as this one, as we describe it as this. This is the intersection A, this intersection of B. And next one, okay, if let's say if two events A and B are mutually exclusive, then B, the probability of A to B is 0, which is going to be described afterwards, after this. Okay, the last one is the complement. The complement of an event consists of all outcomes of the experiment that do not result in event A. So in this case, we write as AC. Okay, in the meantime, the mutual exclusive meant by two events are mutually exclusive if they do not share any common elements. Okay, for example, observing a student in a classroom. Let's say you want to observe a male student as E1, E3, E5, E7, and observe a female student to be E2, E4, and E6. So M and F are mutually exclusive of each other. So I mean to say that something that is not intersect to each other is mutually exclusive, right? Okay, the experiment one. I select a student from the classroom and record his and her hair color and gender. A student has brown hair, B student is female, and C student is male. What is the relationship between events B and C? Okay, what is B and C? Do they have anything in common? No, right? Of course, male cannot be female unless there's a I don't know, transgender or whatever it is. But male is male and female is female. All right. So, mean to say that it is mutually exclusive. And for AC, what about the AC? Student does not have brown hair. Okay, this is based on the experiment. So that's why just now it is mentioned that it is mentioned previously that it is all the results and everything, which is the event, is the outcome of the experiment. And the meantime, B intercept of C, do they have any? So student is both male and female. So I mean to say that, let's say the number of student of female is 20, the male is 20, so it's going to be 40. And B union of C, so in this case that students is either male or female. So it's going to be all